Welcome everyone to the webinar on the total climate impact of aviation. My name is Magdalena Heuwieser. I'm campaigner at Stay Grounded, and we are having this webinar in a very right moment, I think, because we are awaiting a EU study, EASA report to the EU Commission that was supposed to be released several months ago and was postponed several times, and we're hoping that it will be released next week. And finally, a report about the total climate impact of aviation on the non-CO2 effects. Something where a lot of confusion has been about. There have been many different figures circulating. There has been the information used a lot by the aviation lobby, but also by regulators, that aviation is only responsible for 2% of climate heating, which is not correct. It is a lot more. And Stay Grounded has been organizing a working group in the last month, reading all scientific papers, and mostly now also analyzing the new article published in September by David Lee, chairman of the EASA committee, plus 20 scientists prominent in the field. And we have developed a fact sheet and released it on the 22nd of October on this total climate impact of aviation, trying to translate the quite complicated scientific findings of this article, and also calculating a number that was somehow not exactly mentioned in this report. We are planning to react also to the EU Commission's report and follow this up. I think it is a very important issue that we as a civil society also need to have in mind, so that regulators finally do include the total climate impact of aviation into their calculations and into climate policy. So we have a quite interesting agenda. First, Eric Lombard from Stay Grounded France, Rester sur Terre. He was chairing the working group at Stay Grounded on the total climate impact of aviation, and he will explain to us the latest figures and what they mean, how they are calculated. Then we will have Mark Stettler from the Imperial College, not really with us, but a video by him. He couldn't join himself. Where he will explain how mitigation of climate forcing of contrails works. And then we will have an input by Bill Hemmings, aviation consultant, on the question of what could and should regulators do with these new scientific findings. And we will have questions and discussion already in between and also in the end. All right. Just before we start with Eric's presentation, I just would like to very quickly know who is here in the room with us. Maybe you just quickly write where you're based at right now in the chat, so that we know where people are joining us from. So until now, we have Germany, Austria, France, UK, Belgium, Netherlands, Portugal, UK, Alaska, Australia, Portugal, Denmark, France again. Great. What an international group here. And just very quickly, maybe also, what is your affiliation? Like, are you here to represent an organization, or are you here as an individual? So that we have an overview. So we have participants from Stay Grounded, Terre, Alternativa, Climaximo, Milieu Défensif, Friends of the Earth Netherlands, Destination 1.5, Sommersonder Fliegen, Bewaar JV Bindelsen, Collectif de Déboulonneurs, Flight Free Australia, Sea Balance India. All right, thank you. Okay, so now I hand on to Eric Lombard for a presentation of the newest scientific findings.
So good morning. My name is Eric Lombard. I am a member, as Lena said, I am a member of Stay Grounded and coordinate the network in France. The name is Rester sur Terre. I have a master in aerosol physics and atmospheric pollution and worked for 8 years in R&D in the oil industry. I have been sharing the group on non-CO2 effects on climate that recently published a fact sheet and what needs to be done. As Lena said, this work is based to a large extent on a scientific article published in September this year in Atmospheric Environment by David Lee and 20 other scientists prominent in the field. David Lee is a professor at the Manchester Metropolitan University. He's also an IPCC reviewer and was the chairman of the group that prepared the EC report to come. His article can be considered as state of the art. My talk will answer two main questions. What are the non-CO2 impacts of aviation and how much is it? And at the end, I will explain the new method used by David Lee and his team that opens the way to a new argument in favor of the degrowth of aviation. Next slide, please. So let's start with CO2. CO2 is produced by the combustion of kerosene in reactors. The emissions in 2018 were 1 gigaton, 1,000 of million tons. CO2 is also produced in upstream operations, refining and distribution of kerosene, what's it's called the well to tank, and it's not small. It's 200 million tons on top of the 1,000 million tons, and so that's in total. Aviation today contributes to all human-caused CO2 by 2.9%, 2.4 in flight and 0.5 upstream. CO2, as you know, is a long-lived greenhouse gas. It accumulates in the atmosphere, and after 100 years, there's still 30% of it in the atmosphere. Next slide. The NOx, nitrogen oxides, are the results of the oxidation of nitrogen from the air at the high temperatures that prevail in the reactors. NOx, nitrogen oxides, are not greenhouse gases by themselves and should not be confused with N2O, the nitrous oxide, which is a powerful greenhouse gas emitted by fertilizers. So NOx are not greenhouse gas by themselves, but react in the upper atmosphere to produce ozone, which is a greenhouse gas with a lifespan of about 1 month, which has an heating effect. And also NOx destroy methane, a greenhouse gas with a lifespan of about 12 years, which has this destruction has a cooling effect. But overall, NOx have an heating effect on the atmosphere. Next slide. Now let's come to the condensation trails or contrails and to contrail cirrus. As you may know, water vapor resulting from the combustion of kerosene can condense in contact with cold and humid air at high altitudes, forming trails of ice crystals. The condensations, however, requires soot particles that act as condensation nuclei. Contrail lifespan can be very short, generally less than 1 hour. In some atmospheric conditions, contrails can then turn into cirrus with a lifespan of about 1 day. Contrail cirrus are much more harmful than contrails, with about 90% of the radiative forcing and only about 10% for the contrails themselves. Contrail and contrail cirrus can cool the atmosphere during the day, not all the day, but in some periods of the day, but heat it during the night. But overall, they have a strong heating effect. What's important to know is that very few flights account for most of the energy forcing. 2% of flights account for 80% of the energy forcing, as you will see in Mark's video that we'll show later. Yes, so we saw CO2, NOx, and contrail cirrus that have a cooling that all have a heating effect, but there are also minor emissions that are quite small, and I won't talk about them here. So these are water vapor, sulfates, and soot. Then the next slide. Let's how much does how much does aviation contribute to climate heating? That's a question that is dealt with in two different ways. You can either look at into the past and consider the global heating that we observe today, which is a bit more than 1 degree C, and how much of it has been caused by aviation emissions, of past aviation emissions. But the heating goes on. It will not stop at 1 degree C. Every year it increases by a fraction of a degree. So the other question is how much of this additional heating is caused by aviation. Next slide. So to the first question, historical contribution of aviation, the answer given by Lee and his team is that radiative forcing of aviation is responsible of 3.5% of the heating observed to date. This is based on data of the year 2011. And this 3.5% as a result of CO2 accumulated since the beginning of aviation. So for one third of the 3.5%, that is 1.2% only for CO2. And the two other thirds are the result of short-lived non-CO2 that constantly appear and vanish as long as there are planes in the sky. That's 2.3%. Next slide.
Just shortly, Eric, can you speak up a little bit?
Okay.
Louder. Yes. Thank
you. I get closer to the microphone. Is it better?
Wonderful. Thank
Okay.
you.
So the next question is how much, and the most important question is how much aviation does contribute today by its ongoing emissions to the additional heating that's increased every year. That's something that was not provided by Lee's article, but we could calculate based on his data. So today, in 2018, aviation emissions account for 5.9% of all human-caused additional heating. This is the combination of CO2 emissions from oil well flow flights, so one gigaton CO2 per year from the reactors and 0.2 gigaton CO2 per year from upstream operations from well to tank. And the non-CO2 emissions account for 2/3, 2.1 gigaton CO2 equivalent per year. That's a total of 3.3 gigaton CO2 per year equivalent, to be compared to the annual total human caused emissions of 56.1 gigaton CO2 per year. So that's 5.9%. Next slide. So this infographics is a summary of what I just said. So the important thing is this rectangle. You can see CO2 is 1/3 and non-CO2 is 2/3. So in total, the total impact of aviation is 3 times the impact of CO2. And this is valid either for what we observe today, consequence of the past, or for what planes, aviation emits today, which will make the future heating of the planet. Next slide. As you have understood, aviation has already contributed 3.5 to the currently observed heating. It's what has been retained from Lee's recent article in most articles and reports about this work, but it's a result of past air traffic. What's important for the future is what we are doing now. And today, before COVID, obviously, aviation emissions account for 5.9% of all human-caused additional heating. It's what we must all say now. And another consequence, as I already said, multiply CO2 by 3 is valid for the past as well as for the present emissions. Next slide. Now let's come to a bit more difficult part of my presentation. It's how this 5.9% was calculated, on which basis. And in fact, Lee and his team used a different calculation, a different method that normally used by the IPCC. The IPCC usually uses the GWP 100, so global warming potential over 100 years. But this approach is not fully satisfactory, especially for very short-lived species. And that's why David Lee and his team have put forward a new flow-based method based on GWP star. So global warming potential star means it's a new method. Let's think of radiative forcing as blankets that keep the Earth warm. For a short-lived blanket like the one formed by Contrails cirrus, jet planes are a source of a flow. Well, it's why it's called a flow-based, a flow of cloudiness that can change the thickness of the blanket. you can imagine if air traffic is constant, the thickness of the blanket remains constant. There are as many contrail cirrus being formed as disappearing. But if air traffic grows, the thickness of the blanket increases. And on the contrary, if air traffic decreases, the thickness decreases. Therefore, with this new method, adding CO2 equivalent for contrail cirrus and other non-CO2 emissions is only necessary if traffic grows. Next slide. So why use GWP star rather than GWP or GTP? GTP is global temperature potential, which is a bit different from global warming potential. In fact, GWP star was not proposed for aviation, but was first proposed for methane and is now extended to very short-lived emission of aviation. The pros of using GWP star is that it preserves the link between emissions and warming or cooling of the atmosphere, which GWP does not do good. And also it's less dependent on time horizon. As you can see on the table underneath, you have three different values for GWP for 20 years, or for 50 years, or for 100 years. The number represented here is a multiplier. So how much you should multiply CO2 emissions to get the total emissions. So you can see that for GWP 20, you should multiply by 4, for 50 years by 2.3, and for 100 years by 1.7. With a GWP star, Lee and his team say that over the period of 20 to 100 years, you can keep a constant factor of 3, a constant multiplier. Next slide. So GWP star is a change in our way of thinking of non-CO2 emissions. In the old way, we were adding a non-CO2 burden to every flight, and this burden is proportional to CO2 emissions. But with GWP star method, with the flow-based method, we need to add something only if air traffic is growing, if the blanket increases in thickness, and which was the case before COVID, not the case today, but has been the case for more than 20 years. And the non-CO2 burden is proportional to traffic growth and must be added to aviation as a whole, not to individual flights. Or if you want to add it to individual flights, you have to do it on the base of fair share logic, attribute to every flight a fair share of the whole non-CO2 emissions, of the whole non-CO2 burden. Scientists have determined an equivalence between the increments in effective radiative forcing and CO2. Every increase of the blanket thickness of 1 milliwatt per square meter is equivalent to 1 gigaton CO2. And they have determined that for the last 18 years, the average increase of non-CO2 radiative forcing has been 2 milliwatt per square meter per year. So the multiplication is quite easy. So 2 milliwatt per square meter per year multiplied by 1 gigaton is rounded to 2 gigaton CO2 per equivalent per year. So you can see how the previous figures were calculated. The total total emissions of aviation without the well-to-tank are 3.1 CO2 equivalent. So 1 gigaton CO2 and 2.1 gigaton CO2 equivalent. And to this, you can add the 0.2 well-to-tank, which makes 3.3 total CO2 emissions. Next and last slide. So as I was saying at the beginning, this is a new argument for degrowing aviation, because if you degrow aviation, you reduce the thickness of the non-CO2 blanket that is over our heads. And this is really equivalent to CO2 negative emissions. That means withdrawing CO2 from the atmosphere, like the trees do in growing. And this has an immediate effect. And the potential of this is quite large, because currently the radiative forcing has an equivalent of 67 gigatons CO2, which is twice the emissions of aviation since aviation began, and 1.6 times the annual worldwide emissions of CO2. So if we stop aviation, which has almost occurred during the COVID, we have a lot of benefits. That's for me, and I hand over to Lena.
Thank you very much, Eric, for this very comprehensive presentation. I think I finally understood a lot. It is a complicated issue. I think the radiative forcing, understood as a blanket, is very illustrative, and I finally, understand that the COVID-19 induced pause in aviation is really a great relief for the atmosphere, since the blanket is very small and it directly reduces a lot more emissions than we have thought. I wonder if this moment is also a very good moment for new scientific research about the radiative forcing impact. I invite you to ask questions of understanding here. Something you might not have understood. You can raise your hand in the chat by writing a star, or you can write your question into the chat if you don't want to speak yourself.
Maybe, Lena, before giving time for questions, I forgot to mention in the next slide. I'm showing in the next slide the material we have published to summarize the work of the group. So there is a fact sheet on the left. It's a PDF file of 3 pages and an infographic that you already saw, and conclusions about the facts and our demands.
Exactly. So the very short summary of this can be found in the fact sheet on the Stay Grounded website. I just have one small summary and maybe also question. So the paper by Lee basically says that aviation is responsible for 3.5% of climate heating in the past. But also because in the first decades of aviation, there were very few flights, a very big difference to the current numbers or the numbers before COVID-19. So I wonder, why do you think the number of 5.9, which you've calculated and which was also calculated by the Öko Institute, another scientific institution, why do you think this number of the current heating wasn't included in Lee's paper? That would be one question, and then I would just add Sinan's question and then hand on to you, Eric, for the answer.
Hi.
Sinan?
Hello.
We almost don't hear you. Can you speak a bit up?
Hi. Maybe
Yes.
not better? Yeah, sorry.
Still not very loud.
Sorry for this delay. Now it should be better.
Yes, it's better.
Yes. Can you go to the previous slide? Yes, so I'm trying to understand the sentence as a geek. So this, what you're saying is that if we, it's a question, but so let me phrase this the way I understand it, and you tell me if I understood it right. If we stop aviation now, and then if we start calculating the non-CO2 effect of this stop, and then if we wait 10 to 15 years, there would be a saving of 67 gigatons. Is that what you're saying? Is this what it means? Because we have to wait a lot for this effect to, the potential to be realized. It's something like this, right? Thank you.
Okay, maybe Erik, there's also a question by Bram. Maybe we also take on this question, and then I give you the opportunity to answer. Bram?
Actually, I have a lot of questions, but I'll start with one. So we have some sort of overview still in answering the questions. And what would happen to radiative forcing if you flew the planes on biofuels or partly on biofuels? Would that have any effect?
All right, thank you.
Okay. Okay, so the first question, your question, Lena, is quite quick to answer. I don't know. I don't know why they don't did the calculation. Second question from Sinan. Yeah. So if we stop aviation today, if we fully stop aviation today, it's like it has an immediate effect. We don't need to wait for. Yeah, we don't need to wait for 15 years. We need to wait a few days for one day to get the effect of the disappearance of contrails and cirrus. We have to wait about 1 month for ozone to disappear, but and 14 years for methane. But methane is a cooling it's a cooling effect, so it's a bit different because NOx destroy methane. They don't create methane. So it's really an immediate effect, and it's like you were withdrawing 67 gigatons of CO2 from the atmosphere in a few days or months. So it's really efficient, and it's like stopping emitting that all the planets stop emitting CO2 for 1.6 years.
Wow, that's incredible indeed. All right.
And answer to Bram, biofuels. So it's not based on experience, but what scientists say that biofuels would emit less soot, and as you need soot to condense water to form contrails, there would be less contrails. But for NOx, that should be the same. Yeah, but what we can say today. And you will hear from Mark Stettler in his video. He said that biofuel could have a benefic effect, but not on synthetic fuels. It's not. There is no data yet.
Okay, thank you. Are there any further questions, Sinan? Or first, Hans, but it's a one-time effect, no? I guess that relates to Sinan's question. Or maybe do you want to explain, Hans?
Yes, no, yeah, it was the observation actually. You have this effect one time if you stop aviation and don't restart it again, yeah, because otherwise you would the effect would be the opposite.
Yes, sure. Yeah, it's a one-time
stop
effect.
forever. Yeah.
Yeah.
Okay. Thank you.
Okay, and
And I
Sinan?
can add to this that with this new way of calculating with the GWP star, every time you in a period where aviation grows, you have to add to CO2 emission, and in a period where aviation would degrow, then you would have to subtract from CO2 emissions.
Okay, Sinan, and then Anne, and then Finlay.
Yeah, this is still a bit confusing for me. I mean, I think I understand it, but it's a bit, I mean, it's also what you're doing, right? You're proposing a counterintuitive way of, or let's say, less common sense way of seeing this. So what you're saying is we stop aviation now, and for an entire year, we don't emit any, there's no aviation, but the world continues. What you're saying is that we would have negative emissions equivalent to 60% of the emissions today for an entire year. Is that what you're saying then? Like if we stop aviation now, we would have negative aviation worldwide. I'm sorry, negative emissions worldwide, 0.6 times the actual emissions for a year or for a month. I don't know what this number means, because it looks like you're using, when you say it has an immediate effect, how I read this is you're using some kind of GWP 1 day or GWP 1 week. This is the kind of feeling I'm getting, but then you put the potential of gigatons and I get confused again. Sorry.
Yeah. So that's these gigaton are an equivalent in CO2 of the contrail cirrus blanket. So if you take this blanket out of the sky, then it's like you were withdrawing 67 gigatons of CO2, like you plant trees that absorb 67 gigatons of CO2 in one day or in 1 month. So that's equivalent to, so this quantity is huge. It's the equivalent what the planet is currently emitting in 1.6 year. So it's like it's compensating, it's offsetting, I would say, it's offsetting the emissions of the planet for 1.6 years.
Thank you. This is mind-blowing, and this also it's also because it's also the reason why it's so confusing for me. Yeah, thanks a lot.
And we, I can mention that there is currently research done by DLR scientists. DLR is a center for air and space travel in Germany, and they are looking at the effect of the COVID pandemic on this non-CO2 blankets, and we are looking forward to their results.
All right. Anne.
Yeah, thanks. That will be very interesting. I think those results. Thank you very much. It was very, within its complexity, it was very comprehensive and understandable for me, this presentation. I would still like to go back to this question of Sinan, or the to understand it better, that now through COVID-19, it kind of, yeah, for some weeks, I think in March, aviation, like global aviation, nearly stopped, right? It was down to around 10%. So we should have had nearly this effect that you described there. But then it started a bit again. So here I think I still don't get exactly what's the correlation if you stop it for 1 year and then you would start slowly building it up again, then would it directly reverse this negative emissions with starting it again, or would it need to build again over 100 years like it did now, like what you described, that over 100 years it accumulated to 3.5%, and now if we stopped aviation for like 1 year, then we have this negative impact, but then when it would start again, would it directly eat this up again? This I think I still didn't really understand.
Finlay and Larry, are your questions also related to this topic? Then I would ask you to also raise your questions now. If not, I would take you later.
Yeah, I'll just do a quick one. I was just thinking in terms of trying to explain it, thinking about you've got the Earth's surface, then the atmosphere, and then space, and greenhouse gases are yeah, they're like a blanket that help. But you could kind of think of it like you've got CO2, which is a gas, and then the clouds are like having a layer of glass that also keep heat in, or a blanket. And it's almost like if you stop flying, the clouds will very quickly disappear, and that layer of glass will disappear, and you'll allow some heat to immediately be released. But as soon as you put it back on, it's like putting that glass back in place again. So it's like it can quickly go and quickly come back. But it's not really equivalent to like taking carbon out of the atmosphere. It works with the accounting, but it's not going to remove this carbon permanently.
Mm-hmm. Yes, I think that's also a good explanation. Larry, is your question also related to this?
Yeah, I just wanted to make a clarification along the lines of what Finlay was saying, but wherever, like on slide 17, you say equivalent, think of it as a heating equivalent. You're not really reducing CO2. You can't do that. Whatever we put in CO2 is there for centuries. So
yes, agree.
It's a little bit of a mind warp, but maybe that helps.
Mm-hmm. Yes, thanks, Larry. It's equivalent.
Okay, thank you. So those were already basically the answers to the question, right? There's one comment in the chat too, which I think is quite important to really, it should be clear to us that these 5.9% of aviation's responsibility is really only produced by a very small minority of the world population who has who's flying. So less than 20% have ever used an airplane, and in 2018 probably very few people or an even smaller percentage of people flew. So this is also something we have to bear in mind, that this is why actually reducing aviation is something very effective for the climate, because not everybody would need to reduce. It would really be especially frequent flyer who would need to change their habits in order to have an immense effect on the climate.
Yes, it's something we mentioned in the fact sheet. I don't remember if we gave numbers, but we mentioned it.
Yes. All right. Okay, so now we would go on with the video clip, and I mean, if you still come up with more questions, we will have time later on to answer them. So we will now put up the video we already mentioned by Mark Stettler from the Imperial College London. Callum, yes, now the video is on. Let's see if the sound works. Okay, we still need to solve some technicalities.
Thanks for the introduction. So my talk this afternoon is on the non-CO2 impacts and mitigating specific climate. Just before I begin, I'll acknowledge my co-authors, Roger Teo, who is a former PhD student now, and Ulrich Schumann at DLR in Germany. So we've heard a bit about CO2 impacts. So what are non-CO2 impacts? Well, essentially they are the climate impacts of aviation resulting from other emission species, not including CO2. So that could include NOx, nitrogen oxides, and also soot particles, which lead to the formation of contrails, these line-shaped clouds in the sky, and that can have effects on cloud cover. So the focus of this talk is on contrails, and on the right-hand side image, you can see an example of a contrail towards the east of the UK, in the red circle, and over time that contrail morphs into a larger cloud structure that covers a significant surface area. So we think that there's general scientific consensus that the radiative forcing effect of contrail cirrus, these cirrus clouds associated with the contrail formation, is comparable to the radiative forcing of is really significant, as I say, comparable to the cumulative effect of all of aviation CO2 emissions. But we also know that there's some higher uncertainty associated with these contrails and their climate effect. An important thing to point out is that not all contrails are equal. So firstly, not all flights will form a contrail, and the contrails that are formed aren't equal in their effect. So that's again a difference with CO2, where we know that 1 kilogram of CO2 emitted anywhere will have the same effect pretty much. Contrails are very different. So their effect can depend on the emissions of the aircraft, on the meteorological conditions that the aircraft flies through, on the time of day and season that flight occurs, and the surface of the Earth over which that flight is occurring, so the surface albedo. One of the important parameters is the aircraft black carbon particle emissions. So this is the number of soot particles that are being emitted by the aircraft engine. And this influences the optical properties of the contrail and the lifetime of the contrail. So in the literature, people have looked at various ways to mitigate contrail impacts. They've looked at alternative fuels, flight diversions, and cleaner burning engines. And it's the mechanism by which alternative fuels operate is that they reduce the soot particle emissions from engines, and there's some evidence in the bottom left-hand corner here on the slide that some measurements at cruise level that having a 50-50 blend of a HEFA fuel with Jet A reduced significantly by up to about half the soot particle emissions. Flight diversions work by avoiding regions of the atmosphere where a contrail would form. So in order for a contrail to form, you need a soot particle on which the ice can nucleate, but you also need the conditions to be very cold and quite humid. So if you don't have those atmospheric conditions, you won't get a contrail that forms and persists. And cleaner burning engines are engines that produce less soot because they more completely combust the fuel and produce less soot. So what I'll talk about today is the outputs of a project, and we published most of this in a paper published earlier this year in Environmental Science and Technology. Our objective was to evaluate the potential to reduce contrail impacts with flight diversion strategies. And by diversion here, we mean small changes in the altitude of flights and also cleaner burning engines. Very briefly, the methodology of our research was to take a data set of aircraft flights, and this happened to be over Japan. We then had a model for aircraft fuel consumption, for aircraft emissions. We took data for the meteorology and radiation, so weather conditions, and fed those into a contrail model called COSIP. Using that, we were able to calculate the climate forcing associated with individual contrails and therefore individual flights. And then we've also been able to recently look at whether what we're proposing has any knock-on effects on air traffic management, but that's at a more early stage. So this is just an overview of all of the flights that we had within the database. So we had 6 one-week periods of data from Japanese airspace and very high resolution air traffic trajectory data. So approximately 0.1 hertz in the years 2012 to 2013. I mentioned previously that black carbon emissions are important. These particles form the site on which water can condense and form the ice crystals that make up the contrail. So the top figure shows a typical flight profile. The altitude of that flight is in the red curve, and then the blue curve represents the emissions index, so the number of black carbon particles that are being emitted per kilogram of fuel burned. And that's for a conventional engine. So there is some variation, and on average for this flight, there's an average of 1.6 times 10 to the 15 particles emitted per kilogram of fuel burned. We also evaluated the effect of cleaner burning double annular combustor engines, and that reduces the emissions index by about 75%, so down to about 0.4 times 10 to the 15 particles per kilogram of fuel burned. And that leads to a different profile of the emissions shown in the bottom figure. So a similar altitude profile, but the blue line showing the emissions of those cleaner burning engines is significantly different to the top figure. And that's because there's 2 operating modes for that engine, producing different emissions. Another thing to note about contrails, and when we're thinking about comparing them to the CO2 effects, is that they have very different lifetimes, timescales over which they have an effect. So CO2, if we emit it into the atmosphere, remains in the atmosphere for hundreds of years. And in contrast, a contrail may last for up to a day. And once it dissipates, its effect is essentially zero. So we accounted for that using the energy forcing metric, which essentially calculates the amount of energy that is retained within the atmosphere over the lifetime of the contrail, or alternatively over the lifetime of CO2 over a given time horizon. And we've evaluated it over different time horizons, but most of the results I'll share are for a 100-year time horizon, which is consistent with various other climate regulations. So in terms of the results, what we're doing is we're simulating the contrails associated with each individual flight, and what that enables us to do is to look at the impact of specific flights and the number of flights that are forming contrails. And on average for these 6 weeks in Japanese airspace, about 18% of flights form contrails. On average, those contrails last about 3 hours. And the energy forcing associated with contrails is about 1.6 times the energy forcing associated with the CO2 emissions from those flights. So again, this is emphasizing the fact that these contrail effects are really significant relative to even the CO2 effects. And what you see on the left-hand figure is how there's a pattern to the contrail formation, and there's a diurnal pattern. And also in terms of the bottom figure, the contrail energy forcing follows this diurnal pattern. So we get a greater warming effect during the nighttime period because during the daytime, contrails also act to reflect some sunlight back out to space. So now we've got contrail effects of each individual flight. We can put them in rank order and then look at the cumulative contrail energy forcing. And what this shows us, this graph, is that 2% of flights contribute to 80% of this contrail energy forcing. So just 2% of flights account for 80% of the warming effect associated with contrails. So that tells us straight away that thinking about diverting all flights to avoid contrails is completely unnecessary. We could just focus on those 2% of flights that form contrails. So putting that in another way, you may have heard about the CO2 multiplier or the non-CO2 multiplier, and typically that's thought of as being about 2. So you take the CO2 emissions of the flight, you multiply it by 2, and that gives you the total climate impact. But that 2 is a very, very average figure. And what this data is showing us is that some flights have a multiplier of 10 or more. Most flights have a multiplier of 1, i.e. they don't form a contrail. Some flights have a negative multiplier, which means that the contrail that they form actually has a cooling effect. So we can start to play with these flights and think about changing the altitude of them to reduce these contrail impacts. And the reason why we can do that is because these areas of the atmosphere where contrails form are very thin. So this is showing the meteorological conditions over time, specifically the relative humidity at different flight levels. And there's a different pattern in that relative humidity at these different flight levels. So by changing flight level by plus or minus 2,000 feet, you could avoid a region of the atmosphere where contrails are formed. If we then do that, so we take the worst flights in terms of the contrails, and we choose to divert them either up 2,000 feet or down 2,000 feet, we can make significant reductions in the contrail energy forcing. So this figure here shows that if we divert 1.7% of flights in this region, we can reduce the energy forcing associated with contrails by about 60%. And previous studies have thought that that would induce a really significant CO2 impact, so you burn more fuel if you divert flights. But because we're only changing the altitude by a small amount, and because we're only doing that for a small number of flights, the effect on CO2 is really small. So over the total fleet, the effect on CO2 is an increase of only 0.014%. For the diverted flights, it's an average of 0.3%. But because of that, that's really small CO2 penalty. We're getting the benefit of the reduction in the contrail energy forcing. So if we sum up the energy forcing associated with contrails and CO2 and apply this diversion strategy, we're reducing the total energy forcing by about 36%. So on to using cleaner burning fuels. Well, if you have a cleaner burning fuel, you're producing less soot emissions. That means the same amount of water vapor is condensing onto a smaller number of soot particles. So that ends up giving you a larger ice particle, and that changes the optical properties of the contrail. It also changes the lifetime of the contrail, because those larger ice crystals might be they're heavier, and so they sediment out of the atmosphere into warmer layers of the atmosphere more quickly. Introducing these cleaner engines across all of the fleet would reduce the energy forcing from contrails by about 69%. And if we combine these cleaner burning engines, and you could potentially think of that as being cleaner burning fuels as well, with diversions, then we get a really significant 92% reduction in the energy forcing associated with the contrails. So comparing these approaches, so starting off, the small scale diversion leads to 36% reduction in total energy forcing. Cleaner engines leads to 42% reduction in energy forcing. Combining those two together, we get a 57% reduction in energy forcing. If we divert also to minimize contrail energy forcing, that is to say, we form cooling contrails, we can even offset all of the warming effect associated with the contrails. So to summarize, this is diverting flights, changing altitude, something that could be done very, very quickly. The effect of it would be immediate, but also if we decided that it wasn't something we wanted to do anymore, the effect of turning it off would be immediate too. So I'll just leave these results off here and just finally say that in terms of e-fuels specifically, we need more evidence on the emissions associated with burning e-fuels in aircraft engines.
Okay, thanks a lot. I think this was also a very comprehensive explanation by Mark Stettler. Erik, I have one question to you. So he spoke of the multiplier factor of 2 for the total climate impact, is that because this video I think was from spring 2020, so it was released before the new study by Lee and others, which says the factor is 3. Maybe you can just answer on that, and then I think you also wanted to do a quick summary of this video.
Okay, do you hear me?
Yes.
Okay. Yeah, he mentions this 2 multiplier because it's a multiplier that has been using in the UK for some time. That's a kind of official multiplier. So in France we have the same. In Germany it has been a bit higher. Austria too. But you may have noticed in his video at some point he said that the energy forcing of Contrails cirrus is 1.6 times the one of CO2. So that's very close to what we say, because it's only for Contrails cirrus. If you add NOx, then it would be more than 2, and 2 plus CO2 is 1. That's more than 3. So it's really consistent with what we say from Lee's paper. And I also must add, to be fully honest, that Lee put forward this 3 multiplier, but he also say that there are multiple ways of dealing with a non-CO2, and as you could see with the GWP or the GTP, you can get lower or higher multipliers. So now let me summarize what Mark was saying on the slide, because maybe some of you have not seen very well his slides. So Callum, can you show the slide 20?
Or Anne?
Or Anne, yeah. Yeah, that's it. So he says that so 18% of flights are forming contrails. The maximum warming occurs between 3 p.m. and 6 a.m. and even some cooling may occur in daytime. And 2.2% of the flights are generating 80% of the energy forcing. So, and in his simulation, which he simulated very small changes in flight altitude, plus or minus 2,000 feet, on only 1.7 of the flights, and he was able to reduce the energy forcing of contrails by 59%, and the total energy forcing, so CO2 plus contrails plus NOx, by 36%, with only a CO2 penalty of 0.01% for the total fleet that they had been considering.
Okay, thank you, Eric. So there has been some discussion going on in the chat. Also, a bit this question: why has this not been considered? I mean, this is not so new that the non-CO2 effects can be reduced by changing the engine and the flight paths. So maybe I also ask you, Bill, for the next presentation on what should regulators do. Why do you think this has not been considered yet, those flight changes and engine changes. Was it effective lobbying by the industry because it's cheaper to use the old engines and flight routes? And what can be done so that regulators take science into account? So I now hand over to Bill Hemmings, who is an aviation consultant, formerly worked in the aviation industry, and then was several years working for Transport and Environment on aviation. Maybe you can still go into the presentation mode for your slides. Yes. Now, please go ahead, Bill.
Thanks, Lena. Good morning, everybody. As I go through, I'll try and answer some of the questions, particularly the conversation we've just been having now about contrail avoidance. Everything is complicated, and I think it's worth stating at the beginning that this is an inexact science. I'm not trying to defend what hasn't happened in the past, but I think any climate scientist that you talk to will say that these are difficult issues. Their understanding remains incomplete, and one of the reasons certainly why industry and regulators have not done anything so far is because of these scientific uncertainties. And I don't think anyone is saying that the uncertainties have been overcome, but some uncertainties have been lessened, and therefore maybe some courses of action are more assured now in terms of their likely impacts, and therefore on a precautionary basis is now the time to take action. I want to focus a bit on, as was mentioned, this report that's coming from European regulators. I mean, the background is that, I don't know, probably 20, 25 years ago, very few scientists really understood much at all about the non-CO2 impacts of aviation. Even then, CO2 was pretty well understood, certainly by the oil majors, because they started to cover it up. But it's only in the last 20 or 25 years that the impacts of aviation at altitude has started to be understood well. Back in 2007, the IPCC came out with a report suggesting that this really needs to be looked at seriously, because the non-CO2 impacts could be 2 to 4 times that of aviation CO2 alone. So when aviation was being included in the ETS in 2008, there was a long debate about having a multiplier. So if you had to buy one allowance for CO2, you might have to buy one or more allowances for the non-CO2 impacts. The Parliament pushed that, the European Parliament pushed that strongly, but it was resisted perhaps on justifiable grounds then, that from a technical perspective, if you focus on CO2 mitigation at an engine level, the risk is that you will increase NOx from engines, because that's the way combustion works. And so the risk could have been that you might have skewed engine development away from also reducing NOx, and I'll talk about NOx later. So the proposal for a multiplier was not agreed to, but the Commission in 2008, in the original aviation ETS directive, was to look into NOx and to look into other impacts and come back. So the Commission spent a lot of money on CE Delft and about 20 scientists, and they produced a 100-page long report on the NOx impacts of aviation, recommending a NOx charge related to distance. And that has sat on the shelves ever since. So in 2017, when the ETS was being revised again for the 4th compliance period from 2021, the Parliament insisted that the issue be looked at again. And you can read here exactly what the task for the Commission was to do. They did nothing for over a year, and they were hauled back in front of the Environment Committee, and it was rather embarrassing. They admitted they'd done nothing, but we promised to do something. It took them another 6 months to find 170,000 euros, and the job was given to EASA, who are a technical regulatory body. They immediately outsourced the work to a consortium led by David Lee from Manchester Metropolitan University. We'll probably come back to that slide. David's a nice guy. I've known him since I started work on ICAO in 2008. He's led the climate team at MMU in Manchester. He's also been the scientific advisor on the UK delegation to ICAO for many years, probably 20 years. He is the co-lead of the Impacts and Science group at ICAO, which informally looks into all sorts of scientific questions and produces sort of unofficial reports. He is also an advisor to the Department of Transport of the United Kingdom government. Let's just say that a fuss was kicked up by certain people that the group of people in EASA who were to work on this should be a wider group than just the MMU consortium. And so I don't know the actual number of scientists and experts who worked on the EASA report, but certainly some key figures from DLR in Germany who've been the basic leaders on most of this research for the past 5 or more, if not years, have been included. 3 working groups were formed. David Lee led the one on climate impacts. Bethan Owen, also from MMU, led the working group on looking at mitigation options. And Jasper Fabre from CE Delft was asked to coordinate issues about regulatory options. So as you saw, the Parliament was supposed to report by January of this year, but didn't, and they were delayed. At this stage, since we've been waiting 15 years to get a report, I guess we could wait a bit longer, and we expect it actually this week. The question was always going to be whether the scientific report would be published, and the Commission wouldn't commit to that. But now I understand it's likely that most of what will be published will actually be the scientists' report. So I put here in red what is critical, and why is this report critical? We've had IPCC reports and we've had updates. We've had various scientists, including the consortium led by David Lee, who came forward with a published report a couple of months ago. Plenty of other scientists, you can go in and see the literature. ICAO has never talked officially about non-CO2. They regard the uncertainties as too great to actually take the issue that seriously. So in fact, this report to the European Parliament is the first time governments, regulators have ever been asked formally to put down in writing their views on non-CO2 impacts. So the question is going to be, if it's just the EASA study of scientists, in many respects, it's just another bunch of scientists producing a report. I don't want to denigrate that. But the real issue is, what does the European Commission say about this issue? And let's see if it comes out this week, but I understand it might only be 1 or 2 pages, attaching essentially the scientific report. If it is, and if they don't come forward with some substantive discussion and analysis of mitigation options and regulatory options, I would argue that they have failed in their job. Their job wasn't just to produce another scientific report. That was the first part of the job. Their job was, if appropriate, to look and propose regulatory options. This is just a report to the European Parliament. If they were to propose regulatory options, they would have to make a proposal and approved by the college. So let's see. The first thing I think we should argue for is, and this has been mentioned, if indeed it's not just CO2, but it's 3 times CO2, which is the climate impact, then this should be reflected in all sorts of emissions inventories on a CO2 equivalent basis. And there are various you know, already national governments are required to report domestic aviation emissions in UNFCCC inventories, because international aviation is outside, but domestic emissions belong to individual countries. For the international aviation emissions, they're a MEMO item in UNFCCC reports. ICAO, you could also ask whether they are likely to ever do it, and I can't imagine that would happen anytime soon. But at the EU level and at the national level around the world, national states have to produce GHG inventories. The EU also produces a GHG inventory to the UNFCCC. And as we know, Europe has a 2030 reduction target, which they're going to adjust, and they have a 2050 target they have to meet. So if aviation is 3 times the amount of CO2 that's in these targets to be reduced, if you put non-CO2 in there as well, then the targets become higher. And I don't think we should underestimate that this is the hottest of hot political potatoes, because then if aviation is about the size of the emissions of Germany on a CO2 basis, it's going to be about the size of 3 Germanys on the basis of non-CO2, roughly. First hurdle. I think for us, what's important then is to take this reality that it's 3 times the CO2 and get this to be known publicly. And the way to do that, I would suggest, would be when you book a flight. Some websites will have a figure. Some websites will say this flight is greener than the other. We already have, in the case of, we have an eco label for various products produced in the EU. You can't buy a refrigerator now without seeing what the CO2 performance of the refrigerator is. You can't rent an apartment or buy a house. So why shouldn't we have a label which says at the point of sale how much CO2 equivalent this flight is going to be worth? And since the figure will be 3 times what a CO2 figure would be, you can imagine how much pushback that will engender from industry. I don't think the fact that there's going to be pushbacks should worry you guys and gals. To me, that making this reality. So one of the first questions will be, what does the European Commission say about this 3 times CO2 figure? A little birdie tells me that it could be challenged, or it could be ignored. So we need to see whether they even recognize this basic figure of 3 times. They might find it easier to recognize the 3.5% aviation contribution to historical warming. But if they can't even agree to 3, then we'll have a hard time getting this shown at the point of sale. EASA have been working on the voluntary labeling scheme. That was before COVID. I don't know what's happening now. I think an EU law could require all websites that are registered in the EU to show these CO2 equivalents. I don't know, but I think at some stage, if we were to go down this track, someone would need to look at what the legalities are about how and where you can force websites to put this figure on. And then the question will be, well, which figure? Because we've already got various websites which are estimating different numbers for aviation CO2, let alone non-CO2 impacts. Could you have one body that rules, at least in the EU, on this figure? And then the complication is, as we've already heard, that some flights don't create contrails at all, and therefore they have a multiplier of just 1. But you don't know in advance what a flight might do. So that to me is getting these figures in inventories, getting them at the point of sale. Number 3. So the Commission was tasked with, if appropriate, looking at mitigation options. What are they? We can wait for years while radical new aircraft designs come up, and we should still work on that. If you lower the cruising speed and the cruising altitude, that will reduce contrails, but pretty well for that you need to have new aircraft designs. Electric and hydrogen aircraft may well have an impact, a reducing impact on non-CO2, but it's going to be decades before they are around. It was already mentioned by Mark Stettler. We know that cleaner burning engines will reduce the amount of soot and therefore the amount of contrails forming out the back of the aircraft. ICAO have developed a soot standard, but there's been a massive pushback because the costs of developing cleaner burning engines are expensive. There are some leaner burning NOx engines around, but as I said, there's a trade-off and the cost is enormous. As I understand it, the Europeans dumbed down the ICAO standard because there's one major aircraft engine manufacturer in Europe which couldn't meet the standards. I won't mention which one it is, but I believe there are some people who used to work for them on this webinar. Why is NOx important? Well, because when you operate an engine, it is always producing some NOx, as it's always producing some CO2. So whilst this flight might create a contrail or might not create a contrail, all flights burn NOx, create NOx, which has an ultimate warming effect. And so the longer the aircraft, the more NOx, the longer the journey, the more NOx, and therefore NOx is distance dependent, which is why the study 10 years ago led by CE Delft talked about a NOx charge at a distance. We already have a NOx landing and takeoff standard at airports, because NOx produces particulates at ground level. The assumption has been that the NOx emissions at cruise altitude are linear related to the NOx at landing and takeoff. Scientists are not sure whether that linear relationship still holds. There's a possibility at some stage you could have a cruise NOx standard, which might then force manufacturers to try and sort out this trade-off between CO2 and NOx reduction. Cleaner fuels was already mentioned by Mark Stettler as well. There'll be various views on this webinar about whether clean fuels, whether it's biofuels or power to liquid, are a good move, but I think there's little doubt that there is less soot coming from these cleaner fuels, and therefore that in principle should be able to reduce non-CO2. And I'm pretty sure that probably the only recommendation coming from the Commission will be that, well, we're already going to have a clean fuels initiative and try and mandate the use of biofuels and maybe PTL. So that will help reduce soot and non-CO2. So let's just stop it there and not do anything else. And good luck if you can ever get ICAO to agree on a meaningful biofuels initiative. Clearly, if you improve aircraft fuel efficiency in general, you will reduce the amount of CO2 and you'll reduce the amount of non-CO2. Clearly, if you control the recovery of demand after post-COVID through various measures, ETS reform, ticket taxes, fuel taxes, carbon emissions taxes, etc., that will have an impact as well. I don't think we should underestimate the impact of passing on costs and reducing the recovery of aviation. Number 4, contrail avoidance. AIC is aviation-induced cloudiness, which is the contrails and how the contrails then develop into cirrus clouds. And overall, you know, that's about 60% of aviation's climate impacts come from contrail and related contrail effects. So the latest science, as Mark Stettler explained, they were looking for a long time that maybe you'd go around these contrail areas. But now the feeling seems to be that all you need to do is to fly a bit higher or a bit lower. But to do that, you need to be able to predict when the contrails occur. And there's still quite a lot of work to be done on meteorological weather forecasting. You can't just take off and suddenly see, oh, I can see a patch of cold air up ahead, I'm going to go down or going to go up to avoid it. I mean, aviation doesn't work that way. You have to file flight plans and they have to be agreed with air traffic control because it's not just one aircraft in the atmosphere. So predicting when the contrails will occur is difficult. I've been told that maybe within 5 years or maybe within 3 years, if they turbocharge the work, you could more accurately predict if a contrail will occur and change the flight plan. It's not just one flight plan has to be changed, the whole system has to be changed to accommodate a whole series of aircraft may be going lower or higher to avoid this area. I mean, contrails obviously occur in Europe because we see them in the sky every day normally, but it's across the transatlantic where a lot of the weather conditions and the traffic really cause a lot of the contrails. And so Mark Stettler and his group in Greener by Design have been looking at ways based on the research they've done with the Japanese data. You don't need to divert every flight. Maybe 1 in 20 transatlantic flights, as he said, could have a big impact. But again, you know, it sounds easy, just divert 1 in 20 transatlantic flights, but the flights in the 2 directions coming and going, they're all related to each other. And so if you take 1 aircraft down, you have to be aware that the aircraft coming in the other direction, what flights they have. So it's not impossible. As he said, you can do it, but it requires a whole lot of people to agree. It requires regulators to agree that it is a problem that's worth doing. It requires the different air traffic control. And we remember that most air traffic control, not across the Atlantic, but there are 20 or more different national governments who very jealously guard what they're doing. If they could agree to work as one country across Europe, we wouldn't have an air traffic management problem, but we still have. So don't kid yourself that this is going to be easily solved. There is a penalty if you go higher or lower. In both cases, you will burn a little bit more CO2. As Mark said, it's not a lot, but a lot of the arguments against doing anything have been the argument, well, you know, if you create more CO2, it's going to be the atmosphere for hundreds of years. And they're right. You need to be very sure that you're not somehow doing, making a mistake by burning more CO2 in the mistaken belief that you're actually saving it. And so the idea was to do a lot of trials first to see that if you start diverting aircraft, do you really actually avoid creating that contrail? Do a lot of trials and work first before you try and implement it. That work hasn't been done. COVID is obviously slowing everything down. And as I said, what will the EC say? If you have an agreement about how to divert aircraft, should there not be a financial penalty if you don't? Otherwise, what is the penalty? Yes, you could change this flight plan, British Airways, but there has to be some penalty if you don't. So should we not have a charging regime in place first? And so there'll be an economic incentive then, you know, if it's diversion and the CO2 equivalents are included in the emissions trading system or somehow accounted for in ticket taxes, etc., then there would be an incentive to reduce, but they have to be included in some financial way first. I know that the Commission are reluctant to do this in the ETS because they're worried and concerned, let's get rid of free allowances first, and to have a long discussion about non-CO2 impacts in the emissions trading system could upset that apple cart quite seriously. So I know there'll be a lot of reluctance, and I'll be very surprised be very interested to read what the Commission say about including it in the ETS. Remember that on long haul, because of the NOx, whether there's a contrail on that flight or not, long haul flights have a far greater impact in terms of non-CO2 than short haul flights. And you'll see that in the next slide. The UK are talking about a carbon emissions tax. So if you had a carbon emissions tax on the CO2 equivalent, then there'd be a financial incentive to do something about non-CO2. If people want to include it in CORSIA, good luck. I don't want to waste my time on that. As I've said, there is this report out there on a NOx charge with a distance. In itself, a NOx charge is not going to change anything, but it would, as I said, create a financial incentive to do avoidance measures, and for manufacturers, Airbus and Boeing and the GE and Rolls-Royce, etc., to start producing engines with less NOx. It's a lot of money. We're talking about hundreds and hundreds and hundreds of millions of euros to develop these new engines, let alone to put them into the fleet. The last slide comes from a study which I recommend. It's listed at the top there from DLR. And basically they've looked at flights and they've looked at what the non-CO2 impacts would be. And you can see there in the columns distance and cost per mile, and then the CO2 regime versus the CO2 and non-CO2 regime, that for a flight Amsterdam to Paris, the cost per mile of the CO2 regime is 0.09. And for the non-CO2 regime plus the CO2 regime, it's not much more, it's 0.13. So in effect, the multiplier is not very much for a short haul flight, assuming that contrails would have been incurred, but also given that there will be a fixed amount of NOx that depends on the route, the distance, but also the aircraft type and the particular aircraft and engines used. And you can see going down the left-hand column for the different flights that there's a different multiplier. And that for a long-haul flight like Munich-Miami down there, it's significantly higher, as it is from Paris to Los Angeles or from Prague to New York. So a lot of work still needs to be done, but there's some good basis there for sitting down with the Parliament based on this report and saying, you know, have the European Commission taken the scientific evidence seriously, and have they done their job, not just providing an update on the CO2 climate impacts, but on what are the ways we can mitigate it and what are the regulatory ways. So over to stay grounded once this report comes out. Thank you.
Thanks a lot, Bill. This was a very good overview of the last years of basically lacking accounting and regulation. I think it was quite interesting to learn that probably this lack of regulation and accounting has to do with little scientific uncertainty and also difficulties of flight path changes. But also it was very visible that there has not been much pressure from regulators to scale up science and discussions and decisions, something that has to be done now. Maybe a comment that was written in the chat in the meantime by Finlay, also an aviation engineer. He wrote, "I can tell you that the Boeing employee told me over lunch that he thought people were well aware of this non-CO2 effects long ago, but have suppressed discussion of it to avoid it giving them additional headaches, for example, forcing customers to take diversions and adjust altitude more often." So yes, I can also imagine that the industry has done some good lobbying on this, and regulators also feel it's too complicated to include non-CO2 effects because it would change the whole EU emissions trading scheme. It would change the whole inventories that have been made, and it would basically lead to stronger measures, climate measures, something that is already not really well taken care of. So are there any questions to Bill's presentation? Sinan, you have a question?
Yeah, but I'd like to hear the answer because there was a chat and I didn't understand the chat.
Can you just ask your question for all?
Sure. I think it was Larry at some point answering, if I'm not mistaken, Finlay. Some would say that means back to the A380, and I don't know what this means where it was said. I don't understand this comment. I'd like to understand it. Thank you.
Go ahead, Finlay.
Finlay?
I think the idea is we need less aircraft in the sky, so then it's easier for us to adjust different aircraft around each other using air traffic control so that we're flying in the right regions and producing less CO2. And if there's less planes overall, it means you want to pack more people into the individual planes that are flying. So I guess that's why Larry said the Airbus A380 is the biggest passenger aircraft that exists, can fit the most people in it. So if you have rather than 3 different aircraft flying if you put them all into one. And the A380 is actually pretty efficient, but it has kind of been scrapped recently because of the economics. So I think that's what Larry was saying. Does that make sense?
Yeah, exactly. It was in the context of it having been dropped out of production as well.
So it's basically what they could use as an argument, while we could basically say, okay, if we want to test flight routes, then that means we have to reduce flights so that it's easier to.
I just say, I mean, I think it is a great tragedy. One of the tragedies of COVID is that, well, the A380 had design problems right from the word go in terms of fuel efficiency. But the idea that, as Finlay and others said, if you have less aircraft, which are larger and pack more people, then you can deliver the same amount of transportation, but with less impacts both on CO2 and non-CO2. And one of the tragedies is that we're never going to see, probably see an aircraft like the A380 again. Look at shipping, how shipping, the size of shipping has grown, and these large EEE ships can carry 10 times more cargo in one ship than they might have done 10 or 20 years ago. We have economies of scale in shipping, but in fact, the aviation industry is now going in the other direction, and we're going to see more smaller aircraft and more of them probably delivering less transportation on a per unit basis, and that's a bad sign.
But on the other hand, it's the overall passenger miles traveled globally in a year that matters. So size is kind of irrelevant to that. It's just that larger planes would help part of the problem that was discussed.
All right. I have Finlay on the list again, and I just want to invite you to now switch to speaker view, and this way you will see to the gallery view and Zoom, and this way you see all faces and we can have a better discussion. Okay, Finlay.
Yeah, just aware that I've spoken a few times, so put up your hand if someone else wants to speak. I think it's quite, that whole thing is quite interesting though, because if we are going to the aviation industry and we're wanting them to be on our side, it's as well as important to say to them what the benefits of moving to this regulation will be. And if you can say to Airbus, well, actually, it would create this market for the A380, they've lost money on the fact that's been cancelled early. They're not building anymore. The company I was working for, Rolls-Royce, was very keen to re-engine that aircraft. And if you could say, well, actually, there would be more of those specific aircraft and you'd be able to get sales from that as a result of these regulations, it could be a way of getting them on board and showing that we're thinking about them at the same time as trying to regulate the market better. So I quite like that idea.
Bram is on the list.
I had a question that I think more based on Eric's presentation than any other, but maybe Bill knows the answer as well. It's about radiative forcing. We have had basically 3 processes that create radiative forcing. That is contrails, cirrus contrails, and NOx emissions. Now, which percentage of the total amount of radiative forcing is due to those 3 respectively?
Who would like to answer that, Eric?
Yeah, I have the numbers, and you will find them in this paper. Yeah, as Mark was saying, so contrails by themselves is not a lot. The most important effect is cirrus being used by contrails. And NOx, the proportion, it depends on whether you look at the past or if you look at the present emissions. So I have not the figures right now, but I can send them to you offline.
Well, I just
thanks.
That table I showed in the last slide of my presentation, that the length of the flight is determined mainly by the NOx component. So, you know, irrespective of whether there was a contrail or not, NOx, just because it is burning and being produced all the time, is one of the factors. Your answer would give an average across the whole fleet, but in fact, per flight, a long flight could be 3 or 4 times the impact just because of NOx alone, forgetting contrails.
But on the average, cirrus contrails are contrail cirrus are much more than NOx. I would say on a rough estimate would be on 2/3 for contrail cirrus and 1/3 for NOx so within the non-CO2.
Okay, thank you. Hans.
Yes, I just want to remind that maybe it's a little bit illusion to get the aircraft industry on our side, because actually we want to degrow the aviation, and that is what is necessary to get to this 1.5 degrees goal that is on our mindset. So the aircraft have to decrease to a minimum if we want to attain that goal. Yeah, so, and they will understand that easily. So I don't think it's very useful that we lose a lot of time to think about this question to get the aircraft industry, because we are actually against the aircraft industry, and this has to be completely reformed and just transitioned, as we talked about it the other day. Actually implies that they should produce something more useful than aircraft. Thank you.
Thank you, Hans. You got some agreement in the chat, and Anne raised her hand, and then Stuart.
So I was just agreeing. It's just like a way, sorry, it's a way to say, yes, I agree, sorry.
All right. No, but I think there is another Anne too. So there are two Annes in this chat. Yeah, you want to speak?
Thanks, Hans, for this. I think my comment goes into a similar way. For me, it was really very interesting now. There are 3 presentations, and I think it was in a very well order, because in the beginning we heard from, like, I think it's important for us also as people campaigning for degrowth of aviation to understand why it's so important. And now, at least to me, I like this knowledge on non-CO2 effects and this idea of a blanket around the Earth that can be very easily reduced by degrowing aviation makes a very strong argument for reducing aviation. And then in the second presentation, I got the feeling that it would be very easy to just change flight routes, but then with Bill's presentation, I understand again that's actually not that easy. So in the end, I actually come back to the conclusion again that we have very, very good arguments for reducing aviation, not only because of CO2, but also because of non-CO2 effects and the possibility to very quickly even kind of offset, if I may use that word, emissions. And at the same time, we now with this have also the knowledge to counter arguments when people say, okay, do you want totally no flying at all anymore? We can say, no, we agree that there might be some flying needed. And for those flights that remain, we would need to adjust flight routes. And there are very easy ways, or not very easy, but there are ways to do that. And there are ways to develop different engines, but it shouldn't really let us get away from the argument that we need a reduction.
Could I be controversial and say you've got reduction? If COVID's done anything, it's brought international aviation to a standstill. I come from Australia, and Qantas is saying they don't expect to be flying internationally virtually anywhere for another 12 months. So congratulations, for whatever good or bad reason, aviation has been dramatically reduced. The question to me is not reducing aviation now, it is what are we going to do quickly, and what are regulators going to do quickly to stop it growing again? What I'm surprised in this discussion, no one has mentioned point of sale. You know, you can have Extinction Rebellion and people marching in the street to talk about the climate challenges of aviation. Why not talk about telling people clearly when they buy a flight what the real impact is? Who knows at the moment? To me, the challenge now is what immediate actions to stop it growing back. You're never going to stop aviation, I don't believe, but what can we do to stop its rebound very strongly? We all know that people will want to fly again. What are we going to do, and what are governments going to do to contain the rebound?
Yes, I agree. That's an important question. I guess also pushing the EU Commission and Parliament to really take into account this total climate impact of aviation is one of those tasks we have to do in order to not to really consider the whole impact and make this information known to regulators, but also to the common population and media. So maybe that's also a question we might want to discuss in the next 10 minutes. What can we do? What can we do to lobby really now in the next days and weeks, and create and collect some ideas on that. But first, I have Stuart on my list.
Yes, hi. I just wanted, well, first of all, to thank Eric and Bill for their presentations and presenting as clearly as possible what is very complicated science. But as Bill said, that it is an inexact science at this stage. And Eric said after Mark Stettler's video as well, he said, yes, we have to be clear that there are uncertainties here. Mark Stettler stated it in his video as well. And I think it's something we should be aware of, and we shouldn't be afraid to acknowledge the uncertainties and not try and say, well, it's definitely this figure, the other figure, because the uncertainty, it doesn't undermine our message. In fact, on the contrary, uncertainty calls for prudence. And also, I think we need to be aware of it to preempt the greenwashers, because they're going to latch on to the uncertainties which go in their favor, even when there's maybe a 1% chance that something has a cooling effect rather than a heating effect. They're going to latch on to that. So I think we need to be aware of the uncertainties and to be able to counter the arguments of the aviation lobby. That's it.
Definitely. Also something written in the chat, Bill is proposing that all of us, all of our organizations, write to our MEPs, members of European Parliament, and put real pressure on them individually. Finlay.
Yeah, and then I think the uncertainty part is something that's really important in this debate here, because yes, yes, there's uncertainties in these studies, but there's less and less uncertainty. And if you went to these researchers and you said, give me your best case, most optimistic for the climate impact of this, the impact is still high, and that's important. It's like if you're talking 1,000 plus or minus 50 or something, you still know it's high. And the scientific uncertainty is something the oil and gas industry used really effectively to delay regulations on CO2. And there's always been an uncertainty of exactly how much CO2 causes warming, but that's fine. Like, it's still, we know for definite that it causes warming. It's just the exact level. And as an insider of the aviation industry, I know that they're setting themselves up for a fight on this, and they're going to really push the uncertainty on this as their main method of fighting it. So I think it's really important that when we discuss this, really make that clear that the scientific uncertainty is not a uncertainty of whether there's an impact, it's just being how accurate we're being. And I'd try and use that term actually rather than the word uncertainty, because the general public see that as they don't know what they're talking about. So it's really important to ram home that message that the uncertainty is not a reason for inaction.
Yes, all right, thank you, Finlay. Catherine wrote in the chat, I'm living in Toulouse, the city of Airbus. That's a lot of jobs. So our problem is when we say aviation has to decrease, you are killing our families. So I think this is something we have also been discussing in other webinars this week, and that actually it could be an easy demand to say, okay, Airbus, reduce less planes and reduce more trains and keep the jobs. So maybe there are answers we can say to that, and that's why the just transition argument and demand is so important. So I think I missed Carla's. Carla, I think you also raised your hand.
Yeah, what I wanted to mention also to think also when airplanes are going too low, it's also kind of the noises, to keep it in mind that there's also a limit, I think. But what I wanted to mention in the most is that going to Bill's what he meant, how to reach the people also. I proposed once, for example, on the podium of aircraft air industry, to put on their marketing posters what the CO2 impact would be. And it was in the, as said, Wirtschaftsgipfel, so with many people was discussing over it, and the guy told me later, but people wouldn't fly anymore. They say, yeah, perhaps it could happen, but that would be a real information so people can decide. And the other point was that also asking often how the flying industry is working on to getting to the new energies if they wanted to use power to X, because we need in this moment 70% of new energies. If not, it wouldn't be reasonable. And so I try to provoking them in this way. Perhaps it could help. And this final point would to contact Sven Giegold, who is working for the Greens in the European Parliament. I think he would be a good partner, also big with his contacts, all the stuff. Yeah, that was it.
So maybe we just take the last 5 minutes to really collect ideas. Also, what could Stay Grounded do? What could it demand? Would it be maybe even a petition European-wide where individuals can sign up to our demands to the EU Commission and Parliament to really consider this total climate impact, to include the total climate impact on flight information and to include it in regulations? Or would it be that Stay Grounded offers a toolkit for lobbying in your countries and to your MEPs? Or do you have any ideas? Do you have any plans what you want to do and would like to share it here? It's something we can then take with us to the next Stay Grounded network session where we will discuss the next activities. So it would be great to come up with some clear ideas and proposals.
Lena, can I say that a petition is a good idea? You remember the guys from Maastricht did one last year on fuel taxation, but you know, it had problems because you had to give your name and address and who your mother and your father were, etc., and it limited the ability to actually connect signatures. So you could go back and talk to them about how structuring a new petition on this issue of non-CO2.
Yeah, I mean, Stay Grounded did a petition on change.org in spring with the Save People Not Planes campaign, and we gathered more than 100,000 signatures. So this could be a possibility, but yeah, maybe there are other ideas too. And it's, I mean, it is quite some work to do that because then you have to translate it in several languages maybe. And so it's something we could only redo if there's a lot of help from members. Maybe we can also continue discussing this in the plenary session this afternoon. Sinan? Ah, and sorry, I think Hans first raised his hand, but oh, I missed some people. I don't know if Anne was first and then Hans and then Sinan.
Yeah, I would just say that I would be very hesitant to do a petition on this, not just because, I mean, with the other petition, I think we had some impact, but our main impact I saw in influencing NGOs, and with this topic, I think it's really complicated. And now that we had a 2 hours webinar on it, I start understanding some of it, but I have no idea how to put this into a petition text that actually convinces people to really understand how problematic it is and how big is the chance to change something. So I would really much more go for NGOs and big and other players to influence them, to influence others, than to try to make it over getting a high number of citizens to understand and sign this. I mean, we can get the basic message out, but really understanding of how those non-CO2 effects work and why it's so problematic, why it has so much potential that aviation is low now, I'm really doubtful.
Hans?
I actually wasn't able to attend this workshop on lobbying, but we as a Terre sent out an email, maybe it was talked about, an email to the parliamentary groups to present the degrowth of aviation report in Portuguese, and we will take advantage of this fact sheet and to talk about the fact sheet as well. We got one answer so far from the Green Party, so well, let's see what the other parliamentary groups will say. Thank you.
Okay, thank you, Hans. Sinan.
So I have this thing, and sometimes this happens to me when I come up with ideas. When I come up with ideas, sometimes I'm really sad because I cannot do them. So I am imagining a plugin for Firefox, for Chrome, for Safari, an add-on that you can put into your computer that does what was suggested by Bill. It appears as a pop-up explaining that there are emissions, and it sends people to somewhere. So this can happen every time you go to an airline website. It can happen every time you go to a sale website for flights. It may be a short list of like the basic ones, Skyscanner, whatever, and the eDreams, whatever, and then you just do it there. It can have the impact of actually showing some of the calculations. It can feed into Let's Stay Grounded campaign, because individuals could put that in, but also institutions could put that in to all the computers that they have. So for instance, I'm imagining a university having this directly as a default, or an NGO having in the computers as default. You can run an image competition about what kind of images because when Will says something like this, I'm always imagining the cigarette boxes, yeah? Because this is more or less what we are kind of trying to see also. You can run actual image competition about what kind of things that people should see. So this can work. I cannot do it. I'm really, really sorry for suggesting stuff that I wouldn't do. But it's one of those moments when you have one techie guy, it's very easy to do. I mean, it's really, really very easy to do if you know how to code stuff like that. So this could be one thing, and it could involve a lot of artists around this also, because the kind of thing that would show up would also be fed by various kind of information. So this is kind of an idea that I had, but unfortunately I cannot follow up on this because I don't have neither the artistic nor the technological skills for that.
All right, thanks for this creative idea. Maybe some people here might follow up and contact you. Larry, I still have you on the list, and then I would close this webinar.
Yeah, I think Sinan's idea of a plugin is a good idea, as well as just the general carbon calculators that are available or could be improved. But I think the difficulty with those is that they're just a shopping mechanism. Should I choose this airline or this flight or that flight? And I think the trick is to somehow morph those into something that gets people to challenge their thinking of should I fly or take the train, or should I not do this trip at all, or those sort of considerations.
Okay, well, thanks a lot for this very interesting conversation. Thanks a lot for your inputs, Erik and Bill, and the video. I hope we learned a lot. I hope we will bring this back to our organizations and to parliamentarians, and then in the next session in the afternoon, we can discuss more steps we might be able to do. Okay, please, if you have feedback, we include it in the general network feedback form in the end. That would be wonderful. All right, bye-bye. See you later.